Hi there, I'm Dr. Capacitor, your resident expert on all things capacitors here at Nichicon, America. Let me guess, you're here to learn about capacitor dielectrics. You're in luck. I just happen to have a sampling here of my favorite dielectrics with me. And you know what? I got a block of free time, so make yourself comfortable and let's get started. As we all know, it's a big bad world out there filled with capacitors. And our boys are out on the front lines powering technology with a variety of materials we call dielectrics. So, who are these unsung heroes? I'll make it simple for you. You've got your capacitor, you've got your metal plates within the capacitor, and then you've got the insulating material between those metal plates. You guessed it, pal. That's your dielectric material right there. Now you may know dielectrics by some of the more popular types. There's ceramics, aluminum oxide, aluminum polymer, tantalum pentoxide, thin films. What about carbon? They're right here. Of course, the list doesn't stop there, but those are the most common dielectrics. We at Nichicon use what we like to call the Fab Four of dielectrics. They're the classics and we do them best. Aluminum oxide, aluminum polymer, thin films, and carbon. They're like the Beatles of dielectrics. So you may be asking yourself, why does Nichicon have to use so many dielectrics in their capacitors? First of all, don't take that tone with me. Second of all, we have several valid reasons as to why we use the four that we do. There's the cost, the size, and each dielectric's behavior with temperature and frequency, just to name a few. Besides, we don't just insert any dielectric material into any capacitor. We have to be more selective than that. Here's an example. Our industry-leading aluminum electrolytic capacitors are made with aluminum oxide. Our aluminum polymer caps are made using, you guessed it, aluminum polymer. Riddle me this. How do polyester and polypropylene film caps get their names? From the thin films we use to make them. Carbon's a heavy hitter. We use it in our EDLCs, aka supercapacitors or ultracapacitors. Gee whiz, Dr. Capacitor. These dielectrics sound pretty groovy. Can you tell me more? Gladly. Next time someone asks you how many types of dielectrics there are, hold up the peace sign. 2 groups. The first is electrolytic types, home of your aluminum electrolytics, your tantalums, and aluminum polymers. They're called electrolytics because the capacitors in question have a liquid or solid electrolyte in them along with the dielectric. Electrolytes are very conductive compared to dielectrics. This is why it's a team effort inside each electrolytic cap. As my pop always said, there's no I in electrolyte. No two electrolytic capacitors are alike, especially if they contain different electrolytes. But you can always count on electrolytic caps to be polarized, very small, and inexpensive. They also have limited self-healing because every superhero has its limitations. Example time. Aluminum electrolytic capacitors have a liquid electrolyte and can be used up to 100 kilohertz, while aluminum polymer capacitors have a solid electrolyte and an ESR values that are much lower than electrolytic capacitors. They can also be used up to frequencies of 500 kilohertz. Group number 2, electrostatic capacitors. These capacitors are made out of solid materials and are not polarized. You'll find your film and ceramic caps here. Ceramics are typically very small and inexpensive, like electrolytics, but are used at very high frequencies. Film capacitors, on the other hand, tend to be high voltage and very large in size. They can be used in both AC and DC applications and last a long time. Now, I'm a practical guy. And I bet you're wondering about the pros and cons of electrolytic versus electrostatic. You want some tools for your proverbial tool belt. I get it. Get ready for a list of advantages and disadvantages that's going to make you better equipped and wow your friends. Let's start with aluminum electrolytics. I'll give you the downsides first. Remember when I said these caps were polarized? They're only good for DC applications as a result. The life expectancy is going to be shorter than a film cap. Electrolytics are also limited in their capacitance range. They can't be made below 0.1 microfarads. We're only looking at an operating frequency of up to 100 kilohertz. But keep your chin up, because cost, size, availability are all on your side. The material costs are very low, parts are the smallest, and multiple suppliers carry them. The voltage can go as low as 2.5 volts. You can project their life expectancy, and they can have large capacitances reaching several farads in a single container. Finally, vendors make the parts in standardized case sizes, which makes your life a lot easier. Again, these guys are just physically bigger than your electrolytic caps, which could present some limitations. The materials in manufacturing are going to cost more. They've got a lower capacitance range, typically a few picofarads to 100 microfarads is standard. Plus, the case sizes aren't standardized. You've got different vendors doing different things size-wise, which isn't ideal. And yet, there's a light at the end of the tunnel. You need a cap for AC and DC application? Film caps are your guys. A single package can reach several thousand volts and can withstand very large currents without calling it quits. Now, a film capacitor won't recharge on its own, but it will last for several years without failing or drifting. Lastly, as I mentioned before, they're self-healing. At least the metallized ones are. One more thing, then I'll let you go. How do you know which capacitor and dielectric type are right for your application? I'm glad you asked. Once you know the specifics of your application and you remember this little talk we had, you can whittle down to the cap that's best for your application. Let's say the caps are being used in some AC voltage applications. Well, right away you can eliminate all the electrolytic dielectric caps, since they can only be used for DC applications since they are polarized. That leaves film caps. Then you look at the different types of film caps for your specific needs. You'll get it right. I believe in you. Listen, my door is always open. At least it is now. So if you ever have a question, remember the name, Dr. Capacitor.